Welcome to the physics practical session of Vivekananda School, Jogiwala, Dehradun. Physics experiment number 3. The aim of our experiment today is to compare the EMF of two given primary cells using potentiometer. Theory. A potentiometer is an apparatus used for measuring the potential difference between 2 points in an electrical circuit accurately. Its working is based on the principle that the fall of potential across any portion of the wire is directly proportional to the length of that portion, provided the wire is of uniform area of cross section and a constant current is flowing through it. Using a voltmeter, it is possible only to measure the potential difference between the two terminals of a cell. But using a potentiometer, we can determine the value of EMF of a given cell, and for comparing, let's say E1 and E2 are the EMF of two cells and L1 and L2 are the balancing length. When E1 and E2, the two primary cells are connected to the circuit respectively, then we can say E1 upon E2 equals to L1 upon L2. The circuit diagram. So for the circuit diagram, you see this is a 4-wire potentiometer. That means 4 meter. This is 100 centimeter. Then we'll start from here. Again 200, 300 and 400 centimeter. You can see in the potentiometer you have seen these are the only 2 points available. This is the point where we are connecting the battery eliminator, the positive terminal of the battery eliminator. Then the negative terminal is connected to the key and another end of the key is connected to the ammeter, negative of the ammeter, and the positive is connected to the rheostat, and another end of the rheostat is connected to the another terminal of the potentiometer. Now here you can see the two cells and this circuit. This circuit is called the auxiliary circuit, or also we call it as a driver circuit. Now you see the two cells for which we are comparing the EMF. These are the two primary cell. Let's say this is the Daniell cell and E2 is your Leclanché cell. So the positive terminal of both these cells would be connected to the point O. Here you can see the positive terminal of E1 and the positive terminal of E2 is also connected to this point here, and also of the driver cell. And the negative terminal of both the cells is connected to a two-way key. Here is a two-way key. Would be representing your two-way key here. So one terminal is put to negative terminal is put one two-way key, and another cell's negative terminal is also put to the two-way key. In the two-way key there is another terminal also. Three terminals are there and the two positions to insert the key. The third terminal of the two-way key is connected to galvanometer. Then the galvanometer is connected to a resistance box, and in turn the resistance box is connected to the jockey. So here is the circuit diagram, and now we'll be making the connection based on the circuit diagram we have just seen now. Material required for this experiment are a 4-wire or a 10-wire potentiometer. Here we have a 4-wire potentiometer. That means you can see here 4 wires, one which is 100 centimeter, then again 2 wire, 3 wire, 4 wire. 4-wire potentiometer, that means we have
like if it is asked which will be more sensitive, a 4-wire potentiometer or a 10-wire potentiometer. So a 10-wire potentiometer will be more sensitive because for the same EMF applied, if we apply the EMF for the same EMF applied, the potential gradient would be lesser in case of 10-wire potentiometer. Then we require a battery eliminator. It is a battery eliminator, galvanometer, a resistance box, a rheostat, a meter, this one-way key, and we need another key which is a two-way key. So we have a two-way key also. Let me show you. So a two-way key is also needed. This is a two-way key. You can see here two terminals, three terminals here, 1, 2 and 3. So depending on which cell we want to be in circuit, we will keep that key inside and the second key we will take out. And if we want the second cell to be in the circuit, we will keep this key inside and this key would be taken out. So and these are the two cells we'll be comparing the EMF of. This is a Leclanché cell and this one is a Daniell cell. Leclanché cell here, like you can see, in the Leclanché cell, we have made a solution here and this is a porous spot. We have added here in the solution we have made a solution of saturated ammonium chloride and this is our Daniell cell in which in this porous spot we have added dilute sulfuric acid and inside this porous spot here we have added copper sulfate. Again we have made a saturated solution of copper sulfate. So here you can see the zinc rod, these are the two rods in both the cells. The zinc rod would act as a negative terminal and carbon rod would act as a positive terminal. Similarly, again the zinc rod would act as negative and the copper vessel would act as a positive terminal. Clear? So now we will make the circuit arrangement, but before that we will move to the theory. So now we are ready to make the connection based on the circuit diagram we have just now seen. So this is a positive terminal of the battery. So positive terminal here we will connect to the positive. This we will consider as point A like we have seen there. So I am connecting here to the positive terminal. First we will be arranging for the auxiliary circuit. Then we will take the Leclanché and the Daniell cell in the circuit. Now this negative terminal we will connect to the this is the negative terminal. We will connect it to the negative of the ammeter. Negative terminal we are connecting to the negative of the ammeter. This is the negative of the ammeter. Right. Then the positive terminal of the ammeter would be connected to the lower end of the rheostat. We connect it to the lower end of the rheostat. This is the lower end of the rheostat. We connect it to the lower end. Okay. So here we are connected the lower end. The upper end would be connected to the one-way key. This is the upper end. The upper end would be connected to the one-way key. This is the upper end. We would connect it to the one-way key. So one terminal of the one-way key. And another terminal of the one-way key would be going to this point. This was the initial point we started with and this is the second point or point B, we can say. So we are done with this circuit arrangement. So this is the circuit of the auxiliary portion, or we call it the driver circuit. This arrangement is over. Now we will be making the connections for the other two cells for which we are comparing the EMF. So now we have these two cells. This is the Lagrange cell and this is Daniell cell, right? So again, here for this terminal, all the positive terminal would go here. So here, this terminal, this is acting as a positive terminal. So I'll connect it here to the positive, right? And for the Daniell cell also, the positive terminal would go to this terminal only. So let me take another wire. This is the positive one. The copper vessel would act as a positive terminal. So the positive will go again here. The positive has gone to this terminal. Now the negative. In both the cases, the zinc rod acts as a negative terminal. The zinc rod is acting as a negative. So this one is the first zinc rod and this is another zinc rod. So we'll connect it to two-way key now. So we will connect to two-way key. So we connect the terminals to the two-way key. I think this the length of this wire is little less. Let me increase the length of this wire. Connect another wire. This is going to be a little longer. So I have connected this here with one terminal of the. Let me connect it to the one terminal of the two-way key. We'll be using in this full experiment one two-way key and one one-way key. So this has gone here. Now another terminal of the zinc rod of the Lagrange cell will connect it here. So we are done with this much part. Now what do we want to connect a resistance box here. So we will connect it. We will connect with the middle one with the key, this terminal of the key. We will connect to the one end of the resistance box. This is one terminal of the resistance box. Right. And another terminal will connect to the galvanometer. Another terminal will connect to the galvanometer. Galvanometer, positive terminal of the galvanometer. And the negative would be connected to the jockey. And negative would be connected to the jockey. This we are done with the circuit arrangement. All right.